Hello everyone, this is Siddharthan. Welcome to my YouTube channel. In this video, I'm going to give you a complete hands-on tutorial on Numpy in Python. Numpy is one of the most important libraries in Python, which is used in several domains like machine learning, data science, etc. Okay, so in this video, I will be giving you a complete walkthrough of several functions in Numpy and several properties of Numpy arrays. Okay, so if you are new to this channel, in this channel, I'm making a hands-on machine learning course with Python. I will be publishing 3 videos per week. 2 videos will be on this machine learning course order. So these 2 videos will be posted on Monday evening and Wednesday evening. And I will be posting one project video every week, and that video will be posted on Friday evening. Okay. So subscribe to my channel for more videos and stay tuned. So you can join my Telegram group. I'll give the link for the Telegram group in the description of this video so that I can notify you once I post new videos. Okay. So let's get started. First of all, NumPy. So the full form for NumPy is nothing but numerical Python. Okay, so this NumPy is basically used for several numerical operations and other numerical things which we want to do in our project or in our domain. Say, for example, in machine learning, we will encounter large data sets. So data set containing lakhs and even millions of data points and numbers. Okay, so this NumPy library is used for processing that numerical values better and other such kind of things. Okay, so hence it is the short form for numerical Python is NumPy. Okay, so NumPy arrays has two main advantages over list and tuple. So list and tuple are the inbuilt data types in Python, so they store more than one values in a data type. Say, for example, an integer or float can only store one value, but in a list we can store multiple values. So list and tuples are nothing but a collection of values. Okay, and NumPy arrays are, they are just like a list and tuple, but they are more advanced than that. Okay, so the advantages of NumPy array over list is that they allow several mathematical operations to be performed on them compared to list. Okay, so we cannot perform as many operations that we can do on a NumPy array on a list. Okay, so and the other main important thing is the operations that we do on a NumPy array are very faster as compared to list. Okay, so these are the main advantages of it. And so you can see this documentation here, so you can just search for NumPy documentation. So you will find this numpy.org site. So this is where you can find the explanation about the several functions and what is meant by NumPy and what is meant by NumPy arrays and all those kind of things. So if you have any doubt while you are working on this. Okay, so now let's get started with this. So first, in order to use NumPy, you need to import this library. Okay, so for that you just need to give import NumPy. Okay, so now what I'm going to do is I'm going to shorten this NumPy to NP. So I'll import NumPy as NP. So what happens is this will import the NumPy library in the abbreviation NP. Okay, so you can run this. So press Shift plus Enter to run this. So this environment is called as Google Collaboratory. So in this Google Collaboratory, you can run Python codes. So if you are new to this Google Collaboratory, check out my Google Collaboratory basics video, and the index of that video is 2.1. So in that I have explained you how you can use Google Collaboratory and other features of Google Collaboratory. Okay, so here we have successfully imported NumPy. Okay, so as I told you earlier, NumPy is a Python library. So libraries are nothing but pre-made functions and pre-made classes which are stored in a Python file. Okay, so we can access these functions which are pre-made for our programming. Say, for example, there can be 100 line of code. Okay, a particular function can be 100 lines of code, so we don't have to write the entire 100 lines of code. So rather than, what you can do is you can create a module or a library and store that 100 lines of code in a single word or a function. Okay, so using that particular library, you can call that function, and this is the use of libraries. So instead of just recreating the code, you can just call it with a function or libraries. Okay, so that is the use of libraries in Python. So, and here we have this NumPy library, and I have imported NumPy as NP. So as I have told you, the one main advantage of NumPy arrays is that the operations are faster in it. Okay, so I'll just show you how we can find that. So I'll create a text here as list versus NumPy time taken. Okay, so here what I'm going to do is I'm going to perform a simple task on both list and NumPy separately, and I'm going to find the time taken to do that particular operation. Okay, so or that particular process. Okay, So for this I need to import time. So from time, so time is another library. So from time import process time. Okay, so this process time is used to measure the time required for a particular process. Okay, so I'll run this. Okay, now let's see the time taken for a particular task in a list. Time taken by a list. Okay, one second. Okay, so what I'll do is I'll create a Python list. So I'll declare the list as Python list. So we are creating a list named as Python list, and so list should be enclosed in square brackets. And what I'm going to do is I'm going to create a for loop to assign values to this list. Okay, so I for I in range, for I in range, let's say 10,000. Okay, so what I'm basically doing is I want this Python list to have values starting from 1 to 10,000. So that is what I have mentioned through this range 10,000. So I'm creating a for loop that will give the list values from 1 to or 0 to 10,000. Okay, so now what I'm doing is I'm mentioning this start time. Okay, so start time is equal to process time. So we are using this process time to measure the time taken by this particular process. Now what I'm going to do is, so again I'm calling this list Python list, and in this list I'm going to add the value 5 to all the variables. So we have totally we would have 10,000 values, right, from 0 to 10,000. So I'm going to add 5 to all the values in this particular list. Okay, so we can do that by using this line of code. So I plus 5 for I in Python list. So this is the similar for loop as we have used it. So the difference is that, so I'm taking all the values from this Python list, and for each value I am adding the value 5. Okay, so this is the process I'm doing, and I'll just give a end time here. Okay, so end time is equal to process time, and let's print the amount of time required by this particular process. So it can be found by end time minus start time. Okay, so what I'm basically doing is I'm first initiating or creating a list, and in that list I'm putting the values from 0 to 10,000, and I'm creating a start timer here and an end timer here, and between that we have this particular process happening, which is to add 5 to all the values of this particular list. So what happens is we have this start time and end time. So this particular process time function will find the amount of time required or the amount of seconds required for this particular process to complete, and we are finding the difference in it, and this will print the number of seconds taken by this process to complete. Okay, so let's run this. So as you can see, the amount of time required for this particular process, so it's this is in seconds, so it is around 1.7 milliseconds, right? So this is the amount of process taken by a list to complete this particular process. Now what we shall do is, now let's create a numpy array and do the similar process and see how much time a numpy array takes. Okay, so I'll declare the variable as np array, and let's say np array is equal to np dot array. So you can see here I have imported the NumPy library as NP. So I am just calling that NumPy library here, and this NumPy dot array function is used to create arrays. Okay, so NumPy array, I'm just using the same code I have used in the previous cell, which is I for I in range 10,000. Okay, it's the same code that we have used. So I want to create a NumPy array in this case with values from 0 to 10,000, and I'll create a start time. Okay, I'll just copy the code from here. So start time, and now what we will do is we will add this 5 to all the values in this numpy array. So it is the same process that we have done here. So np array plus is equal to 5. Okay, so this is similar to just adding numpy array is equal to numpy array plus 5. So this line, so we have this line, right? So this is similar to this. So np array plus is equal to 5 is similar to numpy array plus 5. So what I'm basically doing is I am adding this value 5 to all the elements of this array. Okay, so that's what I am doing, which is very similar to this process we have done. Okay, so the only difference is that in this case we have added 5 for all the elements in a list, but in this case we are adding 5 to all the elements in a numpy array. Now we need to mention this end time. Okay, so I'll just copy this end time and start time. So this is basically the same process. Now this process again will take place, and for all the values in this numpy array 5 will be added, and the amount of time taken for this process to complete is calculated. Okay, so you can see the difference here. So the time taken for this numpy array to complete is very much less as compared to this particular line, right? So it is almost 5 to 10 percentage faster than the list. Okay, so this is the significance of numpy array. So you can say that this time difference is not much, right? But in this case we are just dealing with 10,000 values, but there are cases where we will deal with a million of data points or million of numbers. So in that case the time difference is quite significant. Okay, so this is one advantage that I have mentioned to you, that in numpy array we can do operations much faster as compared to a list. Okay, so now let's get into numpy arrays. So let's see how we can create numpy arrays and how we can perform several operations or functions on a numpy array. Okay, so I'll create a text as sorry, numpy arrays. So let me show you how you can initiate a list. So we are creating a list here. So list one. So I'm declaring the name of the list as list one, and let's say that the value of this list are 1, 2, 3, 4, and 5. Okay. So I want to print this list, print list one, and I want to check the data type of the list. Okay. So type list. Okay, so first let's create a list and see. So as you know, the list should be enclosed in square brackets. Okay, so this type list will give us the data type of this particular data type. Okay, of this particular object. So you can okay, sorry, it's list one. Okay, as you can see here, we have printed the list and we have found the data type of this particular object as list. Okay, now let's do the same for numpy array. I'll declare the numpy array as np array, and this numpy array is equal to, let's say, np dot array, which is equal to, so you need to pay attention to this parenthesis and square brackets. So you need to mention this parenthesis first, and inside this we need to create a list and put the elements in this particular square brackets. Okay, so we are going to create a numpy array and the values are same to this. Okay, so 1, 2, 3, 4, 5. Okay, so now I'll print this numpy array, so np array, and also I'll check the data type once. Type np array. Okay, so this is an example of a numpy array. So you can see here in list the elements are separated by comma, but in this case the values or elements are not separated by comma in the case of numpy. Okay, and we have found the data type to be numpy.nd array. So nd represents n dimension array. So arrays are similar to matrices. Okay, so we would have studied about vectors and matrices in mathematics. So this array is similar to a matrix in matrix. Okay, so let's see how we can create these kind of arrays and more dimensional arrays. Okay, so creating a one dimensional array. So it is the same as we have done here. So I'll declare the variable as a. So the name of the array will be a in this case. So a is equal to np dot array, and let's say the values are 1, 2, 3, and 4. And now we can print a. Okay, so we have successfully printed the numpy array here. Now what you can do is we can check the shape of this numpy array. This particular function shape will give us the number of rows and columns in that particular numpy array. Okay, So you can see here we have only one value because this numpy array is one dimensional. So this 4 represents we have 4 columns. Okay, so now let's create a two-dimensional array. So I'll create, or I'll declare the variable as b. So b is equal to np dot array, and what I'll do is, let's say the values are 1, 2, 3, and 4, 5, 6, 7, and 8. Okay, so now let me print b. As you can see here, this is similar to a 2 cross 4 matrix containing 2 rows and 4 columns, right? So this is how you can create arrays with multiple dimensions. So in this case, we have just created a one dimensional array containing one row, but here we have created an array with 2 rows and 4 columns. So now you can check the shape of b. Okay, so the first value represents the number of rows and the second value represents the number of columns. So we have 2 rows and 4 columns in the case of the array B. Okay, so in this case we have just only one dimension, so we have just one number here. Okay, so in this case 4 represents the number of columns, but in this case, so the first value represents the number of rows and the second value represents the number of columns. So totally we have 2 rows and 4 columns in this case. Now let's do another thing. I'll create another array as c is equal to np dot array. And so as you can see here, all the values are integers in this case, right? So now let's see how we can put values with floating points. Floating points are nothing but the decimal values. So np dot array, which is equal to, let's say 1, 2, 3, and 4, and 5, 6, 7, and 8. Okay, and now you can mention the data type as d type. So d type represents data type float. Okay, now let's print c. As you can see here, now we have floating point values, which is this is similar to 1.0, 2.0, etc. So by mentioning the data type float, so you can create an array with floating point values. So if you don't mention any data types, the default value is integers, so we get an array of integer values. Okay, so now let's discuss about placeholders in array. So now we are going to discuss about initial placeholders in Numpy arrays. Okay, so these initial placeholders are nothing but in some cases we want to initiate arrays with certain values. Say for example, in several cases we may need to initialize an array in which all the values are 0. In some other cases we need the initial values to be 1 in all the values. So such kind of things. So that is meant by initial placeholder. So initial placeholder means the initial values present in that particular numpy array. Okay, so now let's create a numpy array of zeros. So let's name the array as x. So x is equal to np dot zeros. So zeros is the function which is used to create an array containing all the values as 0. So in this particular parenthesis, you need to mention the shape of your array. 4 comma 5. Let's say that we want to create an array of 4 rows and 5 columns, and we need all the values to be 0. Okay, so that's what we are trying to do here. So you can note here that I have used 2 parentheses here. So inside this parenthesis I have mentioned the shape of the array that I want. So now let me print x. Okay, now as you can see here, we have created an array with all the values as 0 of 4 rows and 5 columns. Okay, so you need to use this np.zeros function, and inside that you need to mention the dimension of the array that you need. Now let's create a numpy array with all the values as 1. Okay, create a numpy array of ones. So I'll create the numpy array as y. So np.ones is the function that's used to create array with value 1. So now let's put the shape of the array as, let's say, 3 comma 3. Okay, so I want a 3 comma 3 array with all the values as 1. Let's print y. As you can see here, we have created a 3 cross 3 array with all the values as 1. So this is some example of initiating an array with the values as 0 and 1. Now let's see how we can create an array of a particular value. Okay, so particular value. So let's say that the array is z and z is equal to np dot full. This full function helps us to create an array with a specific value. So first you need to mention the shape or the dimension of the array you want. So let's say that I want an array of 5 comma 4 shape. So it means 5 rows and 4 columns, right? And next you need to mention the value which you want to give. Let's say that I want a 4 cross 5 array or 4 cross 5 matrix with all the values as 5. And now let me print z. As you can see here, we have got a 5 rows and 4 column matrix with all the value as 5. Okay, so this is how you can create an array with a specific value. Now let's see how we can create an identity matrix. So create an identity matrix. So we would have studied about this identity matrix in our basic mathematics. So this identity matrix means all the diagonal values will be having the value of 1 and other values will be 0. Okay, so this identity matrix is also used in various cases in our programming. So I'll create the numpy as a, and for creating an identity matrix you need to use the function I. So np.I, and in that mention the shape of your matrix. Okay, now you should not mention the number of rows and columns, because identity matrix have the same number of rows and columns. Okay, so we cannot have a identity matrix of 5 comma 4 array, or we cannot have an identity matrix of 4 comma 5 array. Okay, so in the case of identity matrix, the number of rows and columns should be equal. So example, this case, so the number of rows and columns is equal. So in such case we can have an identity matrix, or in case where the shape of the array is 4 cross 4 or 5 cross 5, so those kind of things. So you need to mention. So let's say that we want identity matrix of 4 rows into 4 columns. Okay, so let's print a now. As you can see here, we got an identity matrix where all the diagonal values is equal to 1 and the remaining values are nothing but 0. So this is an identity matrix. So you can just change this value and see. So this will give us a 5 cross 5 matrix, but it is an identity matrix. Okay, so this is how we can create identity matrix using np.I function. Okay, so we have just given this pre-made values in this case. So we created array with all the values as zeros and then 1 and a particular value, all those kind of things. Now let's see how we can create an numpy array. So create a numpy array with random values. So I want to create a numpy array with random values. Let's say that the numpy array is b, and you can use the function np.random.random. So in that you need to mention the shape of the array that you want. Let's say that we want a 3 cross 4 matrix, 3 rows 4 column matrix, or 3 cross 4 column, 3 rows 4 column array with random values. So but there is one important thing to note here. So let me run this first. So we got these random values in our numpy array, but the main thing to note here is all the values will be from or all the values will be between 0 and 1. Okay, so let's run this again. We will get some other value. Okay, so we won't get the same value, so we will get some other values, but that value will be between 0 and 1. Okay, so this is how we can create a numpy array with random values. Now let's see how we can create an array with random values, but we need random integers. Okay, so let's see that. So random values array, and in this case we want integer. Okay, so random integer values array, and we can mention the range we need. So random integer values arrays within a specific range. Okay, so I'll create the numpy arrays as c. So c is equal to np.random. So we have used this random.random function to create numpy arrays with values between 0 and 1. So now you can use this function np.random.randint. So it means random integers. Okay, so now you need to mention the starting and ending point of your value. So here you just need to mention the range in between you want the values to be. Let's say that it's 10 to 100. Okay, and next we need to mention the shape we want. Let's say that we want a 3 rows and 5 column array. So basically what happens is we will get a 3 cross 5 array and all the values will be in the range of 10 to 100. Okay, so now let's print this. So as you can see here, in the previous case we got a decimal values between 0 and 1, and now we have got all the values between 10 and 100. Okay, so this is how you can create a random value array with specifying their starting point and ending point. Okay, so if you run this again, you will get some other value, but the value will be in this range 10 and 100. Okay, so you can change this shape to get a different dimension array. Okay, so next what we will do is, let's see how we can create an array of evenly spaced values. So d is equal to, for this you can use the function np dot linspace. Okay, so np dot linspace, in that you need to mention the starting point and ending point, or the range in which you want the values. Let's say that I want the values between the range 10 to 30. Okay, so I want 5 values in this particular array. Okay, so what I'm doing is I'm mentioning the starting point and ending point and the number of values I need. So let's run this and see. So we will get 5 values between this range 10 to 30, but all these 5 values will be evenly spaced. So I'm running this. So as you can see here, we got 5 values and these 5 values are evenly spaced. Okay, so or you can just use uh, 6 and see. So I want 6 values and they should be evenly spaced, and that value should lie between 10 and 30. Okay, so here we are getting an array of evenly spaced values, and here we are specifying the number of values you want, specifying the number of values required. Okay, so there is another method of creating evenly spaced values, but in this case we can mention the step number. Okay, say I'll just do this and explain you. So array of evenly spaced values, and now we need to specifying the step. Okay, so I'll explain you what is meant by this step. So let's create the array as e. So e is equal to, for this you can use the function a range. So a range, I want the values between 10 and 30, and I want the step value to be 5. Okay, so in this case you need to note here is, so we are not mentioning that I need 5 values. Here we are mentioning that the step should be 5. So if the value starts from 10, the step should be 5. The other value should be 15, 20, 30, 15, 20, 25, like that. Okay, so let's run this. So print e. As you can see here, we get the step as 5. So here we are not mentioning that we need number of values. So here you can see we have only 4 values. So here we are mentioning the step value which we want. Okay, so we want the values to jump with 5 units. So that's what we are mentioning this using this a range function. But in the case of linspace, you will mention the number of values you want. So let's say, for example, in this case, let's mention 5. So these both are the same, but we are just using different function. Let's run and see this. So it will give us 5 evenly spaced values, but this will give us evenly spaced values between this particular range and mentioning this step. So this is how you can create in evenly spaced arrays. Now let's see how we can convert a list to an array. Convert a list to a Numpy array. Okay, so let's declare the list as list2. So let's say that list2 is equal to, so the list should be enclosed in square bracket. Let's say that the list has values 10, 20, 30, 40 and 50. Okay, so let's create a Numpy array as np array, and we can use the function np.asArray. So this np.asArray will convert one particular data type to a Numpy array. So we are converting this list to a Numpy array here. Inside this mention list2. Okay, so this will convert this list2, which is typically a list, to a Numpy array, And now let's print this NP array, and let's also check the data type. Print, sorry, type. So this will give the data type. So let's run this. As you can see here, we have converted this list to a numpy array. As you can see here, there are no comma here. So we have successfully converted this list to into a numpy array, and we have got the data type as numpy.nd array. Okay, so this is how you can convert list to a numpy array. So you can also convert a tuple to a numpy array. So the tuple will be enclosed in parentheses, but the list will be enclosed in square brackets. Okay, so this is how you can convert a different data type to a numpy array. Now let's see how we can analyze a particular array. So analyzing a numpy array. So analyzing is nothing but getting various information about that array. It's just inspecting an array. Okay, so analyzing a numpy array. So let's say that. So let's create an array as C. So C is equal to np dot random. So I want random values. So let's take integer values. So random dot randint. So in that I want the values between, let's say, 10 to 90. And I want a 5 cross 5 matrix. Okay, so I want a 5 cross 5 matrix or 5 cross 5 array with values ranging between 10 and 90. Okay, so I'll also print this C. So print C. So we got a 5 cross 5 array with the values between 10 and 90. So let's do some analysis on this. So you can find the array dimension using this function. So we have already seen this. So array dimension. So what you need to do is, I'm just printing this. So mention the array name. So here in this case, the array is nothing but C. Okay, so put C here. So C dot shape. So this will give us the shape of the array. Shape of the array is nothing but the number of rows and columns. Okay, now let's check the number of dimension it has. So number of dimensions. So let's print. So for that you can use the function C dot ndim. So I'm using C because the name of this particular array is C. Okay, so this is the function we have. So n dot dim. So it means it gives the dimension value. So as you can see here, we have two dimensions. Two dimensions because we have rows and columns here, right? So it is a two-dimensional array. So if you have just a single row, it will be a single dimensional array. As we have rows and columns in this case, it is a double dimensional array, or it is a 2D array. Okay. So you can also check the number of elements present in the array. So checking the number of elements in an array. Let's print C dot size. So this size gives the number of elements. So let's print this. So as you can see here, totally we have 25 values. So we have 5 rows and 5 columns. So totally we have 25 values. So you can find the number of elements present in an array using this size function. Okay. So now let's see how we can check the data type present in this array. Okay. So checking the data type of the values in the array. Okay. So let's print it. So print C dot D type. So D type represents data type. So we know that all the values are integers because we have initiated the random integers values. So it is int 64. That means 64-bit integers values. Okay, so this is how you can find what is the data type present in a particular NumPy array. Okay, so this is about analyzing or inspecting an array. Now let's see some mathematical operations that can be performed on an array. So mathematical operations on a NumPy array or NP array. So I just want to give you another example here. So I need to show that in with the list. So I'll create the list as list1, which is equal to 1, 2, 3, 4, and 5. And I'll create another list as list2, which is equal to 6, 7, 8, 9, and 10. Okay. So now what I'll do is I'll just add both of this list and print it. So let's print list1 plus list2. Okay, so what do you expect this to give? So Let's try to run and see this. So we tried to add this list, but what actually happened is, so when we use this add symbol, the elements are not adding. So the element wise addition is not happening. Say for example, the addition value does not give us the values of 7 and 9 where we add the values element wise. Okay, so in the case of list, when you use this add symbol between two lists, it will concatenate the two list. Okay, so concatenate means just joining the two list. So this plus sign will concatenate or joins two list. So we cannot add or we cannot have element wise addition in the case of list. So concatenate or join two list, but we can do this in the case of numpy arrays. So let's see how we can do that. So let's create a numpy arrays a. So a is equal to np dot, I'll just copy this from above, sorry. Okay, I'll just do this here. So np dot random dot randin. So I want in random integer values, and I want the values between 0 and 10. Okay, so 0 and 10. Now let's mention the shape we want. Let's say I want a 3 cross 3 array, so 3 row and 3 column array, and all the values should be between 0 and 10. And I'll create another array. I'll name this array as b. Okay, so we have two arrays, a and b, and now I want the values between 10 and 20 in this case. Okay, so first array contains value between 0 and 10, and the second array contains value between 10 to 20, and the shape is similar, which is 3 cross 3. So let's run this. Let's print both of these arrays. So print a, and let's print this b. So as you can see here, we got an array with random values. So the first array has values between 0 and 10, and the next array has values between 10 and 20. So now what we can do is we can run some mathematical operations in it. So let's say that it's a plus b. So we want to print a plus b. So in the case of list, when we add the two list, it will concatenate or joins the two list. But in the case of numpy array, when you add two numpy arrays, so we will get element wise addition. Say for example, in this case, the first element is 7 in the first numpy array, and in the second numpy array, the first element is 15. So both these values will be added, so there will be element wise addition. So let's also do a minus b, and let's do all the basic mathematical functions is a into b. So you a into b and a divided by b. So a by b. Okay, so you can run this. So this will give us element wise addition, subtraction, multiplication, and division. So we get four numpy arrays, and all this the element wise operations will be done. Okay, so in the first numpy array, a and b will be added element wise, then it will be subtracted, then it will be multiplied and divided. Okay, so this is one way of doing it, where we just add both of these arrays. So we can do this in another way. So it is, we will just mention np dot add. Okay, so in that you need to mention the two arrays which you want to add. Let's say that we want to add the two numpy arrays a and b. So I'll just copy this, and I'll just make another array here. So I want another a and b. So I'll run this. Now we will have different values for a and b. So let me print that. So print a comma b. Sorry, so print a and print b. So we will get new values for this. So instead of just putting a plus b, what you can do is you can mention this np dot add function. This add function will add two arrays. So I have mentioned a and b. Now print np dot subtract. So this will find the difference between the two arrays element wise. So a comma b, and then we can print np dot multiply a comma b, and finally let's print np dot divide enb. Okay, so let's run this. So this is similar to this particular code, but it is another way of doing that using this np.add and np.subtract function. So we got the four mathematical basic operations performed on a numpy array. Okay, so this is how you can perform some basic mathematical operations on it. Okay, so now let's do some array manipulation. So I'll just create a text here, array manipulation. So let's create an array. So I'll declare the name of the array as array itself. So np dot random dot randint, and I want the values between 0 and 10, and I want the shape of the array to be 2 comma 3. So it will be a 2 row and 3 column matrix as we know. Now I'll just print this array, and also I'll print the shape of this array. So print array dot shape. Okay, so this is similar to a 2 cross 3 matrix where we have 2 rows and 3 columns, right? So now you can create the transpose of this matrix. So I'm going to create the transpose. So let's name the transpose as trans, which is equal to, for that you can use the function np.transpose. Okay, so np.transpose. So inside that mention the array which you want to convert. So I want to convert this particular array and find its transpose. So np.transpose array, and let's print this trans. Okay, and now let's print the shape of this transpose array as well. So trans dot shape. So transpose is nothing but if the matrix is 2 comma 3, it will be converted into a 3 cross 2 matrix. So all the rows will be converted into columns, and the columns will be converted into rows. So if we have the values as 1 2 8 0 7, the values will be 1 8 2 0 and 2 7. So let's run and see this. So as you can see here, the array is transposed. So this is how you can create an array, and you can create the transpose of that particular matrix. So there is another way of finding this transpose. So I'll just copy this array. So it will give us new values. Okay. So as you can see here, now the values are different. So there is another method of finding the transpose. So I'll create another transpose as trans2, which is equal to, so mention the array name. So here the array name is array dot t. So when you mention this dot t, it will find the transpose of this array, and it will store that in this trans2. Okay. So now let's print trans2, and let's print the shape of this trans2. So trans2 dot shape. Okay. So now we can see here that this particular matrix is transposed using this dot t function. So these are the two ways of finding the transpose of a matrix. So now let's see another thing. So this is the last function which we are going to see. So reshaping array. So let's create an array as a, which is equal to np dot random dot randint, and let's say that we want the values between 0 and 10, and I want the shape of the matrix or shape of the array to be 2 comma 3. So it is a 2 rows and 3 column array with values between 0 and 10. So let's print a, and also let's check the shape of a. So a dot shape. So as you can see here, this is the random values which we got. So it is a 2 comma 3 shaped matrix, or 2 comma 3 shaped array. So now you can reshape this array. Let's say that let's create another array as b. So b is equal to a dot reshape, and let's say that 3 comma 2. So in this case we have a 2 comma 3 matrix, and now let's say that I want to convert this to a 3 comma 2 matrix. So in this case it will be a 3 rows and 2 column matrix. So this particular array, which is a, so you can see this is the array a, so this will be converted to a 3 comma 2 array. Okay, so let's, and it will be stored in this array b. Okay, so let's print b, and let's also print the shape of b. So I'll run this. So now you can see here This is how we can reshape array. So this reshape is one of the most important function we will be using in array. Okay, so these are some of the most important functions and the most important properties you need to know about array. So you can make note of this, or you can save this code anything you want, but these are very important. So these can be seem very simple for you, and it is actually very simple, and these will be used in various times when we are working on machine learning projects or any other projects. So this is why NumPy array is very much important for us. So the main thing to note here is the NumPy arrays are very faster than the inbuilt Python data types like list or tuple, and we can do several mathematical operations and other operations as well. So there are also other functions beyond this, but these are the important functions which we will encounter regularly. So I hope you have understood all the things we have done here. So stay tuned to my channel, subscribe and share it with your friends so that we can reach more people as possible. Thanks for watching.